So yeah, hi everyone, I'm Martin Konicek. As you probably know, I'm from the Czech Republic. I'm super excited to be here because I come from a town just 2 hours away from Bratislava. And I work on React Native at Facebook. I'm based in London. We have a team that works mostly on native stuff in London, and then the JavaScript, people who work on JavaScript are based in California. So yeah, with that, let's get started. What I will be talking about. So I have some very quick intro to React Native because Brent already covered all of the, like most of that, and I think many of you already tried React Native. Then I will be talking about how we built the Ads Manager, which was the first app built for both Android and iOS using React Native that we launched. Then I will talk about architecture of React Native, because I thought this might be interesting to you. It's a bit of an advanced topic. And finally, open source. So, as you probably know, React Native lets you build native apps with React, right? It gives you full access to native views on Android and iOS, and APIs as well. If you're building for the web, you're probably used to this amazing experience where you can just reload your page and instantly see your changes. I mean, I have a lot of different backgrounds. I used to work on backend and mobile as well, like native Android apps, and this is just amazing. Like, this is unheard of, right? Just waiting for your app to compile. So yeah, how does this work under the hood? There is a packager. It's a local development server that's running on your laptop. And then this serves all the JavaScript needed to run your app. So it returns a bundle which contains React, your application code, everything. And it can do that very quickly on a small change. So you make a request, and if only one file changed, everything is cached, and it returns you the new bundle very quickly and refreshes your UI. A big thing for me personally about React Native are APIs consistent across platforms. So I don't know how many of you can build apps for both Android and iOS native in Objective-C. I can't do it. It's too much work to learn all of that. With React Native, you only need to learn once how to make network requests or how to write something to disk, right? The same thing with layout. Layout is done using Flexbox, as you probably know. It's also a model that you're already familiar with from the web. And I really like it. I like it better than the Android one, but don't tell anyone. What you might not know is that the Android implementation recently became much faster thanks to this pull request from Lucas Roca, who made it about 50% faster on Android. So the layout engine, right? The engine that computes the positions of the views on the screen. And that was on top of another pull request that he made before that already made it 60% faster than that. So it was very cool. We were very happy that he did this. There's one more Android-specific optimization to the layout. So can you tell the difference between these two pictures? Okay, there is no difference, but they look the same. But under the hood, there is a difference because we've removed some views. We've removed some Android views. So before this optimization, it looked like this. There were views that are only used for layout, but don't have any color or shadow or anything like that. So you declare them in JavaScript, right? In JSX, you declare a view, but in native, it doesn't actually exist because it doesn't need to exist. And this way, Android can save time traversing your view hierarchy. So this means the UI will be more performant. Now, when we know a bit basic stuff about React Native, let's look at how we built the first app that shipped on both platforms with it. And that's the Ads Manager. So this is how it looks on iOS, and this is how it looks on Android. So it does feel really native. I encourage you to try it. Just download it from the App Store or Play Store. The only thing is you need to have Facebook ads to be able to see anything in the app, but if you want, you can just come to me afterwards and you can try the app on my phone. I don't have an iPhone, but I have an Android phone with me. So what did the Ads Manager team realize when they built this? They were the first client of our team, building an app on the top of React Native. So they first built it on iOS without thinking about Android very much. And then they realized it only took 3 months to build the Android version afterwards, which was pretty good. For me, the biggest thing is that they were the same team of people, so they didn't have like dedicated. I mean, we were helping them. The React Native team was helping them, but they were the same team of people, mostly JavaScript developers, with some iOS, some Android people, just built this whole app. Mostly, like it's all written in JavaScript with some native modules. And it also turned out they shared a lot of the code, even though it wasn't the explicit goal. It just happened that a lot of the code can be shared, and I'll talk about it more. So this is how the Ads Manager team felt about it. I asked them, and is it playing? Yeah, cool. So this is how they felt after they shipped the app on both platforms. And this is how I personally felt. So it was something between these two. Yeah. So anyway, like code sharing sounds like a pretty good idea, right? It saves you time. So how do you do that? So let's take a look at this simple example. So this is the app on iOS and Android. And you can see that the screen, this specific screen happens to look the same on both. The designers want it the same. So we share all of the UI code, and we share all of the caching and data fetching logic. How is it done? We just have one JavaScript file which defines this screen. And if you want to make some small platform-specific changes inside this file, you can still do that by checking on which platform you're running on. Another way to split the code by platforms, to have JavaScript behaving differently on Android and iOS, I'll show it here. So imagine you have an example like this, where there's a scroll view, right? And on iOS, it looks like this. It bounces because it is the native iOS scroll view. And it has this nice pull to refresh activity indicator at the top. And on Android, it's the same scroll view with the same contents, but doesn't bounce because it's Android. And it has this native Android pull to refresh. So that's cool. How do we do that? Well, imagine this is just a simplified example. We write a file that has an iOS.js extension, right? And then we say that above the scroll view, please render this activity indicator if we are refreshing. So implementation here doesn't matter, but it's an iOS-specific implementation. And on Android, we have a different implementation, but with the same API. It's still called refreshable scroll view, right? So we split it like this by platform, and then somewhere else in our app, we can just do this, right? We can have one JavaScript file which just renders this, and it will do the right thing. It will only render one or the other based on the platform. So how does it work? You remember the packager I showed in the beginning? That's the local dev server running on your laptop. So an Android phone tells, hey, I'm Android, and iPhone says, I'm iOS. And the packager, based on that, returns JavaScript files, but it also returns a big bundle made out of JavaScript files or iOS.js files or Android.js files to the correct device. Okay. So yeah, this is still pretty simple. Now let's go a little bit deeper. Let's look at architecture, because people often talk about, hey, it's all async and there are like different threads. So what does this all mean? I'll try to explain it. I will be talking more about Android because that's what I'm more familiar with. But a colleague of mine, Tadeu, if you go to his Twitter, you can find he wrote a blog post for iOS, and the architecture is very similar. So at the core of React Native is this thing we call bridge. So you have native code, right, on one side, and you have your JavaScript code running on the other side. And it runs in a JavaScript VM. So on iOS, this VM is already on the system, but on Android, we package it inside your app, which means the Hello World app on Android is about 3.5 megabytes, right? And then what this bridge lets you do, it lets native talk to JS, and the other way around. Is that clear? Right, so let's zoom in a little bit into this. So we have native on one side, the JavaScript running in the virtual machine on the other side. So this is the same picture, just zoomed in. And the bridge is all about calling each other, right? Calling from Java to JS and calling from JS to Java. So how does this work? Let's say we have some JavaScript code and we want to call it. It always starts in native. native decides, hey, let's call some code. So native says, I want to run this application. You open the app, it decides that's the entry point, it decides I want to run your application. So now it sends this call across the C++ bridge, which is serialized, right? And it's a custom protocol that basically says, I want to call app registry run application. That gets unpacked on the other side, and this is what will run in JavaScript, app registry run application. This leads to a bunch of calls in JavaScript, which can be calls back into native, right? So UI manager create view is a JavaScript call that will lead to a native call, which means that that a view and a text view will get created back in native, right? So this is what it looks like, right? Native decides to run an application, then asks the JS, hey, what do you want to do? And then JS returns, I want to have some views and I want to have some text views on the screen. And it's all batched. The important thing is there is not one arrow per call back to native, but you can see that there are 2 calls to create view, but only one arrow going back, which means we wait for everything to finish and then send it all back to native. Can anyone see any disadvantage of this approach related to performance? Yeah, so it's very subtle. Or was there anyone? No. So it's very subtle, but it's about the batching, right? Because imagine the JS is just doing a lot of work, like something computationally expensive, and it decides like I want to render some UI, I want to send 10 network requests to these different domains, and I want to write to disk and do all these other things, and then we all send that as a big batch to native. Why would you do that, right? You can also say, hey, I can render these views in native, meanwhile I'm still running the JavaScript. So we are looking into that. We call it debatching the bridge, and basically means like sending the commands back to native even if you're not done yet, to get like faster TTI, time to interact. Basically the user can do something quicker with the app. Cool, so let's look at the threading model. I talked about some async stuff, like this stuff is happening asynchronously, so what does it actually mean? So you have 3 threads, at least in Java. In iOS, it's similar to this. So you have the main thread, the UI thread. It's the same as you have in browser, or the same as you have in native iOS or Android app. That's just the main thread, which would exist in any app. And then we have 2 additional threads. The JS thread and the native modules thread, where we run the native operations. So now let's imagine that a touch event comes in. It always starts in native. So if you want to ask yourself, like, hey, what does actually happen if I call render in my application, or if I call setState, you should ask the question, what event started this? Because someone probably tapped the screen, right? So let's say the person using your app tapped the screen. There is a touch event in native. That's what would always happen, the same thing as in browser. But what we do is we send this to the JS thread, and this thing will now go across the bridge. This is what you saw on the previous slide. So it will go to C++, to the VM. It will go across the bridge, and it will run your application code, which will say, for example, setState, and that will call render in React, right? So this is where all the JavaScript runs. But while this is happening, you can see that the main thread is separate, as Brent was talking about it, so you can like continue scrolling, for example, in your app at the same time. This thing then goes back to the native modules and says like, hey, here are all these commands that we want to do. That's what you saw on the previous slide. And this thing also recomputes layout. So unlike Android, which does layout in the main thread, we do the layout on a separate thread, which also saves some work for the main application thread. And we compute like, okay, so React from JS tells us this view should be green, this one should be, the size should be 200. So we recompute the layout using CSS layout, and then we finally update the UI on the main thread, because that's what you always have to do. Cool. All of this can happen at 60 frames per second, ideally. So imagine this, where we have an animation that's driven by JavaScript using the animated API. So there is a timer event kicking in native every frame, and then going to JavaScript, and then JavaScript computes positions, and then it's going back to native. So this whole thing basically like can go back and forth like this 60 times a second. And if it doesn't, we might want to introduce some API to offload applications, offload animations into native. So it all happens on one thread, and we don't have to go back and forth like this. Another big thing about the like API of and internals of React Native is the modularity. So what this means basically is React Native, the code base is just it's composed of. I think I will have some water. Just need to running out of breath. So. Yeah, that's better. So, the React Native code base is composed of small modules and view managers, which I will explain here. So, let's say there's a module called dialog, which you can just call from JS like this. And this translates into a native call, into a dialog module, right? And you can have your own modules for anything like this, which I will show in a second. So this is basically how the translation goes from JS into native. Same thing with views. Let's say you have a view or a switch that you declare in your JSX. This gets translated to native like this using an abstraction called view managers. And the reason I'm talking about this, the coolest thing is that you can simply define your own. Right? So there's a view manager that maps text to text view. There is a view manager that maps JavaScript switch into Android switch. And what we ship with React Native, what you get in every Android app is just a list of all these modules and views where you can see, okay, there's storage, there's network support, there is a scroll view, there are images, stuff like that. And if something is missing, well, you can very simply go and implement your own, like we did here in the maps package. So then you go into your application main entry point, which is the main activity, and you just say, besides this main React package, which is the default, I want to also have my maps package, where you implement a view manager for maps. So this is all public API, and it's just like composed out of small bricks or pieces that you can add as you want. And my favorite part about this is that you can then take this maps package that you've just written and ship it to NPM so other people can easily use it in their apps as well. And there's this cool website called React Parts, so if you publish any native modules, you can just register them there, and then you can make it easily searchable for other people. This is actually something I'm working on right now. I wish I had time to do live coding, but I will ship that sometime after this week, so stay tuned for updates. I want to basically make it easy for people to write and consume these modules, right? So yeah, because we don't want to put like everything into the core. So if you have an idea like, oh, I think this feature should be into the core, this feature should be available to other people, then it should be very easy to publish it, and it should be easy for other people to use it. Which brings me to other topic, which is open source. So talking about code sharing and stuff like that. So how do we run the open source project at Facebook? So if you go to our GitHub repo, one thing you will notice that we have now 360 contributors as of sometimes last week, which is for me personally mind-blowing. So these are the people that committed code to React Native. And you've probably also noticed that we do these releases, right? There's going to be 0.14 coming out soon. So we do releases of React Native to NPM. How do we do that? Well, we always have these release notes that there is this very kind guy called James Ide who writes these release notes for us. And yeah, how do we actually do that? So we do development on master, right? We do 2 weeks of development internally at Facebook, and during this time we are using that code. So we are always using master. Like internally at Facebook, when we build the ads manager, we don't use releases. We just use master, which is also good for you because we discover bugs. We discover more bugs this way, right? But for you, what we do is we do a branch cut for people in the community. We do branch cut, and then we have this code which is frozen. But as the development continues, we cherry pick small bug fixes that we find out about, or we cherry pick small features into the release branch, and then we finally ship it to NPM. And then this all repeats, right? Then after the 2 weeks, we got a new release branch. So in this picture, the blue one would be 0.14 at this point, and then the next week is already going to be 0.15, and so on. If you look at the GitHub page, you will notice that there are these commits that we push from the Facebook repo, and they look a bit weird, right? What are all these weird differential revision, and what is the sync ID? What is this all about? And it's pushed by some GitHub bot. What does this mean? So I will explain that. So internally at Facebook, we store the code in Mercurial. So we don't develop on GitHub, but we have this code internally. And the most interesting part for you to look at is this React Native GitHub folder that we have. This is a simplified layout of our code base. We have React Native GitHub folder there. That's what you see on GitHub. But we also have some Facebook-specific extensions, like reporting crashes to our backend. And there's, of course, like the ads manager. So this all lives in a big single repo. And every minute, when we make changes to this folder, we push them to GitHub, right? So how it looks, we make changes using this system called Fabricator. And what Fabricator does is basically something like pull requests. It's an internal system where you send your changes, and we run tests on them. So it's a bit like Travis. The most interesting part here at the bottom are the tests. So the CI system runs tests on your code before it actually gets committed. And at least one person has to review your code and accept it in order for you to commit it. And once you commit it to the internal Facebook code base, then we only take the subset of the files that are open source and we push them to GitHub. And this is what you see in the commit. And the differential revision is the number of that diff that you saw in this slide. So basically, this thing gets synced to GitHub like this. OK, that's very cool. So that's one way, right? We go from internal code base to GitHub. How do we go the other way? This is what I found on Twitter. It was called what happens if someone sends you a pull request. So that's apparently what happens. Yeah, it's good. It's cute. So what happens when someone sends you a pull request, actually? So pull request looks like this. This one was very cool because it was the most commented on pull request. It was changing some core functionality in React Native, and finally we merged it, so I was super happy about that. What happens? Someone sends this pull request, and we have this bot that goes and looks at the files in the pull request and tries to find the people who are the most likely to have knowledge of the code base, the specific part of the code base, right? So it mentions them here, so they get notified. Then once we do the code review, everyone is happy with the pull request. What do? We don't merge it on GitHub because we need to get this code into the Facebook code base. So we say ship it, and then this bot comes in and comments. And what does this link lead to? Well, it leads to a diff. So what it does, it creates a diff in Fabricator, which has exactly the same changes. And why do we do this? Well, the most important part on this screenshot are the tests. So we have to see that the pull request doesn't break the ads manager, for example, right? There's closed source code, and we have to make sure that everything works with this pull request. But when it does, and when we see that everything is good, we merge it in the Facebook code base, and then it goes out to GitHub the same way. And important thing about this is that the author stays the same. So you get attribution. The files on GitHub will blame to you because you wrote the pull request. And we were very happy about this one. I was super happy that we finally merged it. Cool. So just to sum it up, pull requests go from GitHub to the Facebook repo, create diffs, and then go back to GitHub. Cool. OK, so talking about pull requests, how you can help us. If you are looking for something like where should I get started, we have this label for issues called good first task. So we put this label on things that we think are like well-defined, and you can just go and do them. So that's what you can do, how you can get started with pull requests. Another thing is there are issues. There are too many open issues right now, and one reason is that a lot of the issues are really questions, right? And we unfortunately have no way of putting a banner on GitHub saying like, hey, please, if you want to ask a question, go to Stack Overflow. So Stack Overflow is like so much better platform for questions than GitHub issues, right? So you can help us by going there. You can help us by answering questions there if you want. Another thing that we realized recently is GitHub issues don't allow you to prioritize in a good way. So we came up with this idea we started using this website called Product Panes, where you can vote on the things that are the most important, because we want to work on the most important things. So or you can see things that are important, and you can pick them up and work on them. So the most important, high upvoted one right now is Android feature parity, which means open sourcing more views and modules for Android. So yeah, I want to work on that as well when I'm back from vacation. Another thing is documentation. It needs love. This is an example I discovered through Twitter that this is a documentation of how do you run your app on an Android device. These were all the points where people got stuck. So documentation needs love, and especially if you've never used Android, please go there and either tweet at us or send pull requests improving the documentation. That would be amazing, because this saves so much time for everyone, right? So the new version is like much improved. Okay, that's all I have for now. It was a short talk. Thank you all very much. And when I say thank you, I really want to say thanks to the community, because this is a community project, and I've never been part of a more exciting project and more exciting community. So thank you, guys.
Cool. So we've got time for 2-3 questions to answer.
Okay, cool. This is that. What is preventing the core team from replacing Packager by Webpack? Oh yeah, that's I think one of the most common questions. I think you should, like, there's a long discussion about this on one of the GitHub issues, right? And Amjad, who wrote most of the Packager, has been commenting on that. You should really ask him, but I think the reason the main reason was performance. I didn't write the Packager, but yeah, you can find out the issue, or you can tweet at me. I'll send you the issue where this is all being discussed with Amjad. Okay, should I do the next one? Sure. Do you have any idea how? Do you plan Windows Phone support? Not yet.
That was easy. Okay.
Do you have any idea how I can use React Native in languages which are not JS, but compile to JS? Yeah, I haven't actually looked into that, but you can probably add. You could hack the Packager because the Packager already does transformations, right? It uses Babel to transform ES 2015 into the old JavaScript. So you could do something similar. I think it should be possible. But I would have to look into that. Don't know, like, can't tell you exactly, go and do these steps. But yeah, I think it should work. Should I do more?
If you want to.
Yeah. I just don't know how much time I have left.
1 or 2 more questions are good.
Okay. Do you focus on platform parity? Yeah, I want to focus on that. When I'll go on vacation this week, and then I'll focus on that. And more people from the team hopefully will focus on that as well. So we have all these views internally, and we just need to, like, clean up the APIs, make sure it works really well, and then open source them. Why are you not using Gitflow? I don't know what Gitflow is. I should look into it. Okay, I'll look into that.
And one last one, the first one.
Any best practice in handling differences in screen sizes? That's a good question. I mean, you can make your layouts. I mean, you can just use like Flexbox to stretch things across the screen and stuff like that. I don't know if that answers the question. Who asked that? Come to me and we'll talk about it after the talk. Okay? Cool.
Great, cool. Thank you so much.
Thank you.
Thank you.